today is about how solution sets behave. If you find two different solutions, you basically unlocked an infinite membership card. For a linear system, solutions don't come in two-pack mode. It's 0, 1, or a whole buffet. We will also learn how to solve for an unknown matrix using invertibility. Here is the core idea. Linear systems play nice with linear combinations. If x1 and x2 both work, then any weighted average with weights adding to 1 also works. And since there are infinitely many choices of the weights, you get infinitely many solutions. This is the multiply by the inverse move. If A inverse exists, it acts like division for matrices. So X equals B becomes X equals A inverse B, and that gives exactly one answer. Part A is find A inverse using row operations, like in the previous section. Part B is the payoff. Once you have A inverse, you just multiply it by B, and the system stops being scary and starts being a straight computation. This is a cool shortcut. For square matrices, if you manage to prove BA equals the identity, you don't need to separately check AB. It's like finding one working key direction and the door admits it's unlocked. The EST is basically a big, same story, different language theorem. Invertible can be recognized by row reduction, by the homogeneous system, by consistency for all B, and more. Later in the course, this theorem becomes your Swiss Army knife. This is a beautiful construction. If A can hit every target B, then it can hit the special targets E1 through En. Stack those solutions as columns, and you literally manufacture the inverse. The strategy is, build a right inverse or a left inverse using the inverse of AB. Once you get an identity on one side, square matrices can't fake it. They must be invertible. Part A has a dependency in the left-hand side equations, so the right-hand side must match that same dependency. That is why we need the condition B3 equals B1 plus B2. Part B has an invertible coefficient matrix, so every B works and there is exactly one solution each time. This is the matrix version of divide both sides by A, except division is illegal here. So we multiply by A inverse on both sides. Same logic, just wearing a matrix suit. Big message: linear systems don't do two solutions only. Invertibility is the cleanest guarantee. For every B, exactly one X. And when you see AX equals B, remember the move. Multiply on the left by A inverse. But if A inverse doesn't exist, go back to the good old Gaussian elimination.